Well-known buildings, modern buildings. Buildings made of concrete components. This is also a component of concrete, although it is a microscopic one. It gives information to specialists in the research laboratory about materials and quality, information which results in a new vibration technique. Know-how is turned into new products and processes. Concrete mixes resulting from basic research are compression tested daily out of the current production. Also, the new products are tested, here at the research department of the Danish College of Engineering. A full-scale wall cross with a new type of floor component from Højgaard Schultz is being tested. The load on the elements is gradually increased, up to 4 times the normal working load. The industrial building processes start at the 3 factories of Højgaard Schultz. In this part of the factory at Viby, floor components are cast in a process where 60 steel molds move continuously from one stage to the next. After cleaning and oiling of the mold, the reinforcing steel is placed and the side shuttering closed and locked before the mold is moved to the next operation. Steel tubes which form the holes in the hollow floor slabs are operated from a control desk. The concrete mixing plant, as well as the overhead transport to the casting machine, is also directed from the control desk. The concrete is distributed evenly in the mold by means of powerful vibration. The surface is compacted and leveled off with the vibrator drum of the casting machine. Immediately after the concreting, the tubes are pulled out of the floor slab. Every 4 minutes, a floor slab leaves the production line and is stacked in front of the steam curing chamber. After approximately 4 hours steam curing, the slab is lifted back to the production line, the mold being opened simultaneously with robot-like precision. The element is hoisted for inspection and stamping. With 2 shifts each of 6 men, a day's production amounts to 1,000 square meters, corresponding to a total floorage representing 2,500 flats annually. Random samples are taken of each type of component for control, a procedure which ensures high quality and observance of prescribed tolerances. On another production line in the same factory, partition walls are cast in modular sizes, 33 steel molds circulating in a pit below floor level in a continuous process. The electronically controlled mixing plant is operated from a control panel near the casting point. The transport of the ready mix is also remote controlled from the panel. The concrete is emptied into the hopper of the casting machine, which is moved backwards and forwards along the mold for even distribution of the concrete. Immersed needle vibrators ensure optimum compaction. Before the molds are automatically swung over to the casting line, each form half is provided with reinforcement, electrical ducts, socket outlets, and frames for door openings, all locations being determined by the modular system. A hydraulic force of 30 tons is applied to the molds during the concreting and the subsequent curing. The many operations are controlled and coordinated with such precision that a finished wall component is lifted out of the pit every 10 minutes and taken to the storage yard. This gives an annual production of some 110,000 square meters of partition wall, using a labor force of only 10 men split between 2 shifts. From the storage yard, the wall and floor components are transported on special vehicles according to a tight schedule to satisfy the demand from the building sites. The other factory at Vibu also produces wall and floor components, but mainly in larger sizes. Also here, feeding and mixing of materials are electronically controlled, and the technical equipment is continuously being brought up to date. From the batching plant, the concrete is conveyed into the 150-meter-long factory where, for the first time in Denmark, pre-stressed hollow floor slabs are cast as a continuous process. These floor slabs are extruded at a speed of 1 meter per minute. After curing by means of a heating system underneath the mold, the slab is cut into the required lengths with a diamond saw. As floor slabs, these components can span up to 8.5 meters. Whereas they can span as much as 12 meters when used as roof slabs. The daily production of these slabs is about 350 square meters, produced by 5 men in an 8-hour shift, giving an annual production of about 80,000 square meters. After cleaning and oiling of the bottom mold, up to 7 strands are run out, and each is pre-stressed with a force of 12 tons. In combination with an unusually high concrete strength, this ensures the required load-carrying capacity of the long slab components. In another section of the factory, long wall components are concreted in 12 individual steel molds. Before closing and locking the molds, frames for door openings and all fittings are placed in position, without imposing any restrictions on the number and location of these items. A wall panel 6 meters long and only 6 centimeters thick is handled without difficulty when the concrete has obtained a suitable strength after a few hours curing. With this special production technique, it is possible in these molds to cast long walls up to 7.8 meters in length, 3 meters in height, and with thicknesses up to 30 centimeters. With maximum utilization of the available capacity from these two factories, it is possible to produce floors and walls for more than 4,000 flats a year. The factories at Vibu produce exclusively components for floors and walls. The facade units, the character of a building, are produced at the factory at Herlo. Also in this factory, the production is continuous, in a process with steel molds giving the facade units their surface texture by means of a plastic pattern in the bottom of the mold. The first operation is to fill in colored concrete. Thereafter, reinforcement and insulating materials. Finally, normal concrete is placed under heavy vibration. The interior face of the component is screeded immediately before it goes into the curing chamber. After 5 hours accelerated steam curing, the component rolls forward for stripping. The texture of the facade unit is emphasized by a light acid washdown, after which the inspector finally passes the component for the finishing works, with fitting of doors, windows and shutters. In order to solve the problems of the present and the future inside the building industry, as many operations as possible must be done away from the job site, in the factory. In other words, building must be industrialized. In addition to the production of concrete components for their own works, Højgaard Schultz supply concrete components of all types to contractors and builders. In particular, Højgaard Schultz make a substantial contribution to the Danish housing construction through continuous supply to government-subsidized building programs, as illustrated here in a new Copenhagen township comprising more than 3,000 flats. Cooperative societies acting as designers and contractors. The result demonstrates the appeal of concrete as a material to the imagination of the architect in his work with shapes, textures and colors. Intense development is constantly going on in order to improve processes and products, all with the aim of further developing the existing forms of dwellings and other buildings. In this work, full benefit is drawn of the knowledge and experience available from architects and technicians. Such cooperation has, among other things, resulted in a new development project comprising 80 flats, in which Højgaard Schultz technically and functionally is putting to use the ideas of a new building system. The exterior architecture, as well as the layout of the flats in this system, breaks with the conventional concept of multi-story flats. A residential environment of a high standard has been created. Outdoor rooms, bedrooms, bathrooms, toilet and kitchen are placed in independent sections on either side of a narrow house core. This brings daylight to all rooms in the house, and the sound insulation between the individual rooms and flats is improved immensely. Industrialized building requires a thoroughly organized staff for the design, planning, and coordination of all activities in the drawing office, in the factory, and on the site. In the daily work with a building project, here a Højgaard Schultz standard office building and a large warehouse, all possible advantage is taken from the network planning system. Electronic data processing of these networks offers better control of the scheduled operations in the production and transport of the components, in the erection, and in all the other stages of the construction work. The framework of columns and main girders for the large warehouse is erected before the secondary girders, which carry the roofing, are placed in position. The whole project is constantly checked and controlled by the electronic data machines. The components for the fireproof partition walls arrive from the factory at Vibu. Special handling equipment lifts the units and places them in the row of columns. The load-bearing frame with roof for the 20,000 square meter warehouse is erected in only 8 weeks. Ten-meter-high cladding panels are now placed in the framework. They lean against and are fastened to the edge beams of the roof construction. Every half hour, 25 square meters of finished cladding panel with cast-in insulation is hoisted in position in a single crane operation. On September the 28th, the first gable units are erected in the standard office block. The working schedule is strictly followed. Only 10 days later, the erection of the top story is begun. As part of the planning, the office building is, on the drawing, divided into lorry loads, which are carefully checked on arrival at the site. Teamwork is essential for the erection crew, who also benefit from the output of the electronic data machines. As a result, the office building can be closed with the last component only 17 working days after the erection of the first components. Højgaard Schultz build offices and factories, the basis for prosperity and welfare today and tomorrow. Modern places of work for modern people. And Højgaard Schultz build houses for all age groups. Produce components for themselves and for other builders. Højgaard Schultz build schools, functional schools, for the furtherance of modern education. And students' colleges, a rendezvous for young people receiving education of all kinds. And homes for the aged. And other related institutions. Build hotels. Build stadiums and grandstands. Build for people in our modern society. Højgaard Schultz turned building into an industry.